Good morning, students. Today's topic for the session is sampling techniques. So, as you all know, sampling is a popular statistical concept. So, sampling is a great way to pick up a subset of the data and to analyze it. You see, since we have been working, since it's a statistical concept. Now we have been working in data analysis, data analytics, and big data analytics. We may be downloading a relatively a big data set, and we are excited to get started with analyzing it and building the advanced level in this big data analysis is that building a machine learning model and to snap it. So the data which you download from this big data, which will run in a computer, which it goes to out of memory, which will try to load the data set. So it happens to everyone who faces the big data analysis, and it is one of the biggest hurdles that anyone face in data science, dealing with the mass amount of data and computational limited machines. It is not for all machine or all business those who are doing big data analysis. For a limited machines, this is the biggest hurdle and one of the limitation. So to overcome this set of problem, we can what is the solution? So the great way is to pick up a subset of the data and analyze that. So now it can be a good representation of the entire data set. So that is more important in sampling. And sampling is not a new concept of only with the big data analysis. It started from the statistical concept. It has its own origin and evolution in the social science research. But our focus today is about for knowing about the issues of sampling with the big data analysis, and we will be learning the conventional different sampling techniques and sampling methods. So this a sampling has to be taken from the good representation of the entire data set. Okay, that is known as sampling. So we have come across with many of the experience like in our school days and university days. So okay, sampling is a great way to pick up a subset of the data and analyze that. Okay, then the question arises, should we just pick up any subset randomly? That leads to know about the different sampling techniques or simply sampling methods, how to pick up any subset from the, again, make a note, the population. So for today's session, the scope is what is sampling, why do we need sampling, different steps involved in sampling, different types of sampling techniques, types of probability sampling, and types of non-probability sampling. This is going to be the scope for today's presentation. Okay, let me start by formally defining what is sampling. Sampling is a method that allows us to get information about the population based on the statistics from a subset of the population, which is the sample, without having to investigate every individual. So for example, this is the data that we are going to under investigation. So without no need to investigate every individual in the population, so it allows to get information about the population based on the statistics from the subset of the population, which in assumption which has its all the characteristics of a population that a sample contains. So the sample becomes a part of a population, and this process is known as sampling. Here comes what is sampling. So we want for an example from the population to sample to find the average height of all children, male boys children in Tamil Nadu. For example, the population of Tamil Nadu is around 7 crores, and boys children would be roughly around 1.5 crores. So whatever I am telling are general assumptions for this example. So don't take the exact value. So just imagine it is nearly impossible to find the average height of all boy children in Tamil Nadu, and it is also not possible to reach every boys. So we can't really analyze the entire population. So here our population is all boys in Tamil Nadu. So, what can we do instead? Taking multiple samples and calculate the average height of individuals in the selected sample. Here comes the role of sampling technique. Okay, how then the next question? As I said, we will take multiple samples. I said, no, it's not possible to reach every boy. So we can't really analyze the entire population. So we can take multiple samples and calculate the average height of individuals in the selected samples. So that's the role of sampling comes here. Then the next question is, how can we take a sample? Should we take a random sample, or do we have to ask the experts how to go about it? Let's say, for example, if you're going for a basketball court and take the average height of all the professional basketball ball players as our sample, this will not be considered a good sample because generally a basketball player is taller than an average male, and it will give us a bad estimate of the average male's height, which is going to represent the population's characteristics. So this won't be a right choice to have basketball players as a sample to know the height of the boys in Tamil Nadu. So, what is the solution? How can we take a sample? So, randomly, it's not like going taking the basketball players, and the solution is find random people in random situations wherever our sample would not be skewed based on heights. The skewing is the particular skewing towards a particular situation. Okay, so the sampling techniques has to be adopted just blindly, not going to for any sample by going by the experts. So why do we need sampling? So this will give a point regarding the question. Sampling is done to draw conclusions about populations from samples. As I said, no, the characteristics of a sample definitely reflects the characteristics of a population. For example, the boys samples that you have taken definitely is going to reflect the boys population characteristics, and it enables us to determine a population's characteristics by directly observing only a portion or sample of the population. So here what we have to take it seriously is the sample's characteristics is going to reflect the population's characteristics. So by directly observing a portion, only a portion of the population definitely enables us to determine the value to result for the entire population. So selecting a sample requires less time than selecting every item in a population. Sample selection is a cost efficient method. Analysis of the sample is less cumbersome and more practical than an analysis of the entire population. So these things, for these reasons, we should go for sampling. So that is the answer for this. Why do we need sampling? So the next step is, if that is the case, what are the different steps, various steps involved in sampling? Okay, for example, so these are the 5 steps involved in sampling. Step 1, identify and define target population. Step 2, select sampling frame. Step 3, choose sampling methods. Step 4, determine sample size. Step 5, collect the required data. I'll be explaining each and every step in detail. See, for let us take an interesting an example by applying these steps to perform sampling. Assembly elections in Tamil Nadu is going to be in a week or 10 days. So you must have seen the public opinion polls. Every news channel was running at this time. No? So with these results concluded by considering all the 7 crore or all the 5 crore voters of the state or a fraction of these voters. Let's see how it was done. The first stage in the sampling process is to clearly define the target population. That is the step 1. The first stage, clearly define the target population. So, to carry out opinion polls, the polling agencies consider only the people who are above 18 years of age and are eligible to vote in the population. So, for example, in the case of polling predictions, who is going to be the target population? The target population are the people who are above 18 years of age or eligible to vote in the population. They are going to be the target population for our particular case. The second step is the sampling frame. So, sampling frame is a list of items or peoples forming a population from which the sample is taken. So, the sampling frame would be, in our example, be the list of all the people whose names appear on the voters list of a constituency. So, that is going to be the sampling frame. So, if you take the people election polling as your election polling and the target population or the age above 18 people, then the sampling frame would be the people whose names appear on the voter list of a constituency. So, that is the sampling frame. The step 3, the third stage is the probable choose the sampling method. As I said, no, there are two sampling methods broadly: probability sampling method and non-probability sampling method. Generally, probability sampling methods are used because in our case, every vote has equal value and any person can be included in the sample irrespective of the other characteristics or other factors like gender, caste, community, or religion. Different samples are taken from different regions all over the state. So, if you take our own example, irrespective of these other categories, gender, caste, community, low income, high income, so each and every vote has equal value. So, that is which in our case the probability sampling method is generally fit. So, okay, this we will discuss what is the difference between probability sampling and non-probability sampling in the later slides. Then the fourth step, after choosing the sampling method, the fourth step is the sample size. Determine the sample size. It is the number of individuals or items to be taken in a sample that would be enough to make difference about the population with the desired level of accuracy and precision. So, that will help you to go for your accuracy and precision of your results. Larger the sample size, more accurate our inference about the population would be. For the polls, agencies try to get as many people as possible of diverse backgrounds to be included in the sample. It would help in predicting the number of seats a political party can win. So, this is so in some cases it is not it won't be a possible one to have a larger sample size. So, sample size determination, there itself there is a formula that we'll discuss in the next slide. Then we'll finish with the last step. Once the target population, sampling frame, sampling technique, the method and sample size have been established, the next step is to collect data from the sample. So, in opinion polls, agencies generally put questions to the people like which political party are they going to vote, or has the previous party done any work. So, based on the answers, agencies try to interpret who the people of the constitution are going to vote and approximately how many seats a political party going to win. So, this is work very nice. For example, the final stage is the collecting the required data from the sample. I am repeating: identify the defined target population. So, the target population in our case is the people who are all above the age of 18 because we are going to study the opinion polls. The second step, the selecting the sampling frame. The sampling frame would be the number of people, name of the list of the names in the election in that particular constituency. The sampling method generally, because here the why we are telling about insisting probability sampling would be the right sampling method here in this case of opinion polls is each and every vote has its own value irrespective of caste, gender, high class, high income, low income, community, religion. So, probability technique, and the sample size, larger the sample size will give you leads to more accuracy and more precise result. So, how to calculate this sample size? As I said, no, this is I have taken a screenshot of a sample size. So, if your population size, so see the confidence level 95% and confidence level 99% is how accurate and how precision in the which confident you are going to present your result is going to be the confidence level, that is 95% or 99%. If you take 95% of confidence level, then if your population size is 100, then your margin of error for the sample is going to have to be 80. If your population size is 500, then you can go up to 217 samples to be taken at the 5% margin of error. Okay, then if it is 1,278, you see after 5 lakh, 384. So anything above 384 definitely will give you the same result. So 384 will be the maximum. So this is a different technique, different formula is there. Sample size calculation formula is there, sample size determination formula is there to calculate the sample size. So once you know the population size and the confidence level that you're going to analyze, then you can take the formula, apply this formula and find the what you say appropriate size of your samples for the data that you are going to collect. The next we'll go to the another diagram. This talks about different types of sampling techniques available to us. As I said, the sampling methods generally classified into probability sampling and non-probability sampling. So in probability sampling, there are four types: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Under non-probability sampling, convenience sampling, quota sampling, judgment sampling, and snowball sampling. I said earlier, the probability sampling, in probability sampling, every element of the population has an equal chance of being selected. Probability sampling gives us the best chance to create a sample that is truly representative of the population. So if you see the previous diagram, from the population the sample has been taken out using the sampling technique. As I said, no, the characteristics of the sample has to be the reflected in the characteristics of the population. That is how this probability sampling gives you the true representative of the population. Generally, the election case, opinion polls case, each and every case is important. So each and every element or every respondent has to be given an equal chance of being selected. So probability sampling. So if you are doing a study, decide your method, which type of sampling you have to take, and generally we can analyze with these sampling techniques. So if you see the right side, the non-probability sampling, in non-probability sampling all elements do not have an equal chance of being selected. Consequently, there is a significant risk of ending up with a non-representative sample which does not produce generalizable result. Okay, keep this in mind, generalization of result. In probability sampling, if you follow the right and proper sampling technique and sampling method, we can generalize the result. And in the non-probability sampling, which may lead to the error of not producing the generalizable results because it doesn't have a equal chance of being selected. Let me see each and every sampling technique in detail. For example, with this probability and non-probability sampling, let's say our population consists of 20 20 boys or 20 people, 20 children or 20, yeah, we can take it as 20 individuals. Each individuals is numbered from 1 to 20. For example, you take it in mind, our population is 20 individuals. Each individual is numbered from 1 to 20. So and it is represented by a specific color. So I'll show you the picture: red, blue, green, and yellow. So out of 20, each have been given a different color among red, blue, green, and yellow, and numbered as 1, 2, 3, 4, 5, 6, 7 up to 20. Each person would have odds of 1 out of 20 of being chosen in the probability sampling. Equal chance of selection is has to be given in the probability sampling. When non-probability sampling, no, these odds are not equal. A person might have a better chance of being chosen than others. So now the idea of these two sampling type is understand the different types of sampling under each section, which will help you to know more clear understanding about probability and non-probability sampling. Okay, under probability sampling, the first type of sampling technique is the simple random sampling. So this is the individual or the response samples is chosen entirely by chance, and each member of the population has an equal chance of being selected. As I said, no, the number from 1 to 20 under red, green, blue and yellow. The simple random sampling is each individual is chosen entirely by chance and each member of the population has an equal chance of being selected. One big advantage of this technique is most direct method of probability sampling. Okay, this is the most method of probability sampling. We are giving equal importance to the all the individuals, all the elements in the population. So simple random sampling. The next, the systematic sampling under probability sampling is selecting a fixed sampling interval. So systematically, so that's why fixing a sampling interval. Let's take a simple example to understand this. So our population size is x. We have to take a select a sample size of n, that is small n. So the next individual then we will select will be x by nth interval. For example, if your population size is 50 and we have to take 5. So our population, I am repeating, our population size is 50 and we have to select a sample size of 5 samples from that. The next what we can do is 50 by 5. So the intervals every 10th we can select the rest in the same way. So this is the systematic sampling. So here in this diagram we begin with the person number 3. Okay, 1 2 3 we have selected the sample, then 1 2 3 next person, and 1 2 3 11, 1 2 3 15, 1 2 3 19. Okay, so the systematic sampling is like selecting a sample in a fixed sampling interval. The example shown is the interval of 3. So it is very easy. If your population size is 50, or take it as x, and the sample size that you want is small n, just put it as x by nth interval, will give you the systematic sampling method to go with your sample selection. The next probability sampling is the stratified sampling. So here in stratified sampling, we divide the population into subgroups called strata, different strata based on different character traits like gender, category, income, education. Then we select the sample from these subgroups. See, for example, 1 2 3 4 up to 20, we are subgrouping all the red colors 1 7 13 and 15. Okay, that now what the process what we are doing here is the stratification, that is the different strata, and 2 5 12 19 in the yellow, 3 4 10 9 13 under the green, 6 8 9 11 14 16 17 under blue. Okay, now with this strata we will be selecting the each and giving equal chance to each strata. From red we are selected 7, from yellow we selected 5, from green this, and blue 2. Okay, so that shows the weight. So there is some splitting it into subgroups, that is what they call it as stratification. So we use this type of sampling when we want representative from the all subgroups of the population. However, stratified sampling requires proper knowledge of the characteristics of the population. Unless you don't know the characteristics of the population knowledge, then it is not recommended to go for the proper stratification, won't happen. So this type of sampling wants the representation. If you want the representation from all the subgroups of the population, we can go for this stratified sampling. And the next sampling technique is in the probability sampling is cluster sampling. So we use the subgroups of the population. In cluster sampling, we use the subgroups of the population as the sampling unit rather than individual. So the population is divided into subgroups known as clusters, and the whole cluster is randomly selected to be included in the study. You see, in the previous we have stratified in the name of colors, that means any traits like gender, caste, income, anything. But in cluster, irrespective of the traits, we are just subgrouping, making into clusters, and the whole cluster is randomly selected. Okay, 1 2 3 4 and 5 6 7 8. Okay, the cluster, a cluster is selected as our sample 13 14 15 16. See, they have selected 1 2 3 4 5. They have taken the fourth cluster. So So the population is divided into clusters. The sample taken is from the fourth cluster, 13, 14, 15, which represents only the red and blue. So in the above example, we have divided our population into 5 clusters. Each cluster consists of 4 individuals. We have taken the fourth cluster in our sample, which includes more cluster as per our sample. So this type of sampling is used when we focus on a specific region or area. So dividing into subgroups and taking only the clusters. If you want to focus on a particular region or area, I can go for cluster sampling. I am summarizing the probability sampling, simple random sampling. Okay, yeah, simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Simple random sampling, just giving equal importance to the equal chance to each and every individual items or response samples in the population. Systematic random sampling, sampling with the systematic intervals, that we call it as sampling intervals. In our case, we have taken every third individual responses as the systematic sampling. And the stratified sampling, just putting all our samples in strata, in the different straits, like gender, caste. Like here the strata is based on the different colors, red, yellow, green and blue, and after the stratification, selecting the samples is the stratified sampling. And the fourth is the cluster sampling. Out of the population, just dividing into different clusters, and in the clusters it has to be taken, like in any one of the clusters will be taken for the cluster sampling. For example, to study the particular area or particular region, cluster sampling is approach is advised to take it. So that is about the probability sampling. The next is the non-probability sampling. As I said, no, the non-probability sampling, all the elements do not have an equal chance of being selected. That's non-probability sampling. So there is a significant risk of ending up with a non-representative sample, which where we cannot produce a result that go for a generalizability. Okay, so in non-probability sampling, the first technique is convenience sampling, which is the easiest method of sampling because individuals are selected based on their availability and willingness to take part. You see, let's say here in our case, individuals numbered 4, 7, 12, 15 and 20 want to be part of our sample, and hence we will include them in the sample. For example, if you are doing research in your hostel, for a 50 girl students or 50 boy students in your hostel. So out of 50, only number 4, number 7, 12 and 15, 20 want to be part of our sample because they are your friends. So we will include them in the sample. Okay, so this becomes your convenience. Okay, so their willingness to take part, so and our own convenience. So this is the convenience sampling. That is the reason which we cannot go for a generalizing the result for the whole 50 people. The willingness here matters. So that's why the convenience sampling is prone to significant bias, because the sample may not be the representation of the specific characteristics of the as your friends, or say the gender of the population. It won't reflect the whole 50 population of the particular hostel. So this is convenience sampling. The next non-probability sampling technique is quota sampling. In this type of sampling, we choose items based on predetermined characteristics of the population. Consider that we have to select individuals having a numbers in multiples of 4 for our sample. See here, 1 to 20. The individuals numbered 4, 8, 12, 16 and 20 are already reserved for our sample. In quota sampling, the chosen sample may not be the best representation of the characteristics of the population that we are not considered. So based on certain characteristics of the quota, we are selecting the sample. That is also comes under this non-probability sampling technique. Again, we have not given equal chance for all the individuals. Already because of predetermined characteristics of the population, we are going for this quota. The next non-probability sampling is judgment sampling. It is also known as selective sampling. It depends on the judgment of the experts when choosing whom to ask to participate. Suppose our experts believe that people numbered 1, 7, 10, 15 and 19 should be considered for our sample, as they may help us to infer the population in a better way. As you can imagine, Quota sampling is also prone to bias by the experts and may not necessarily be representative. Here, the judgment sampling is, as I said, also known as the selective sampling based on the experts judgment whom they want to collect the data, collect the sample, which could be considered for help us to infer the population in a better way. So this comes from the judgment sampling by the experts. And the last sampling, non-probability sampling technique is the snowball sampling. So existing people are asked to nominate further people known to them so that the sample increases in size like a rolling snowball. So this method of sampling is effective when a sampling frame is difficult to identify. See, after 120, I can say the example, we have randomly chosen person 1 for our sample, and then he recommends person 6, and person 6 recommends person 11. Person 11 recommended 14, and the 14 recommended 19. So 1, 6, 11, 14 and 19 become our sample. So there is a significant risk of selection bias in snowball sampling, as the referenced individual will share common traits with the person who recommends them. For example, I'll tell you whatever we are going with the present day survey questionnaire. So we are creating a survey Google form questionnaire and sharing it to your friends. The number one friend will share to his the friend number 6, and he will be recommending the number 11 to 14, 19. Here the researcher doesn't know number 6, 11 and 14 and 19. He knows only the first person 1, as this says the snowball. It will appear it's a big where we are collecting the data using the Google forms. So I am summarizing the non-probability sampling, uh, convenience sampling, quota sampling, judgment sampling, and snowball sampling. So these are the 4 non-probability sampling techniques. So it is, so what we have seen today is what is sampling, why do we need sampling, steps involved in sampling, different types of sampling techniques, and the types of probability sampling and types of non-probability sampling. So again I am repeating, sampling is a great way to pick up a subset of the data to analyze. Especially it's for big data analysis, it is very difficult to analyze the whole population, which is a bulk of tons and loads of data. And this is also the technique which is followed in the conventional social science research. So why do we need sampling? Again the question is conclusion about the population from the samples with the population characteristics directly observing the only a particular portion, which will tell you the part of the population, which shows the sample is the part of the population which reflects the population characteristics. The steps involved in sampling, as I said, 5 steps: identifying and defining your target population, selecting the sampling frame, choosing the sampling method, determining the sample size, and finally collecting the required data. The different types of probability sampling and types of non-probability sampling: simple random sampling, stratified sampling, simple random sampling, stratified sampling. Just a minute. Different types of sampling techniques. So simple random sampling, systematic sampling, stratified sampling, and cluster sampling comes under probability sampling, and convenience sampling, quota sampling, judgment sampling, snowball sampling comes under non-probability sampling. The only difference between probability and non-probability sampling is, in probability sampling, every element of the population has an equal chance of being selected, which represents the best chance of the truly representative of the population. In non-probability sampling, all elements do not have an equal chance of being selected. This may end up with a significant risk with a non-representative sample, which where we cannot produce our result for generalization. That's it about the sampling techniques. Thank you.